Hi there and welcome to my channel. My name is Erfan and today I've decided to go through this Add Math paper 1 with you guys. This paper is from May-June session 2021 and it's time zone 1. So without any further ado, let's go ahead and take a look at question number 1. Okay, question number 1. Find constants a, b, and c such that this equation holds. So as you can see, the a, b, c which needs to be found is all on the right hand side. So I'm just gonna go ahead and take the left hand side and do a bunch of algebraic manipulation, and hopefully I can unite all the p, q, and r's together and make the comparison. So the first thing I'm going to do, get rid of this square root or the radical sign and rewrite it as a fractional index, p to the power of half. Well, q is good to go. There's no need to change that. Same goes to r. Over here, I'm going to expand the bracket. That means the 2 here belongs to both p and q. The power of p becomes 2. The power of q was already -1. And then now times 2 becomes -2. The power of r remains to be -1. And now I can simply just combine and group them, the p's together, q's together, r's together. This is a matter of subtraction since I'm dealing with division. So half minus 2, that's the new power for p. 2/3 minus -2, that's the power of q. And -3 minus -1, that would be -2, of course. And this is what I get. That means a has to be -3/2, b has to be 8/3, and c has to be -2. Question number 2. We are given a particle which moves in a straight line such that its displacement, s meters, from a fixed point at time t seconds, where t is greater than or equal to 0, can be modeled by this function. So in part A, I have to find the exact speed of the particle when t is equal to 1. So since I'm given the displacement function, I can find the velocity function by simply taking derivative of this with respect to time, as I did here. So this, since this is a composite function, I have to use chain rule. That means I'm gonna take the derivative of outside, -half comes in front, and then multiply it by the derivative of inside. So derivative of inside is basically the coefficient of t, which is 3, goes there. And don't forget, you need to subtract 1 from the old power to get the new power. And then you tidy up. This is the function. Now all I have to do is to substitute the t with 1 in order to find the exact speed when t equals to 1. You make the substitution inside the bracket. I get 4 to the power of -3/2, or you can use a calculator. However, what I did here, I took the square root of 4 first, because that's what 2 here means. So this is basically 4 to the power of 2 and then raised to the power of -3. So 4 to the power of half is 2. 2 to the power of -3 is 1/8, as you can see here. And then you multiply by -3/2, you get -3/16. Now this is the velocity. You have to be careful. Speed cannot be negative. We are asked to find the speed. Therefore, the speed is the magnitude of this value, which is 3/16. In part B, I have to show that the acceleration of the particle will never be 0. So I'm just going to go ahead and take derivative of my velocity function, which I obtained in previous part, because that's how we can get the acceleration, by taking derivative of velocity function with respect to t. And again, I have to apply chain rule, derivative of outside. I already showed that in green color. So the power goes in front. You subtract 1 from the existing power and you multiply by the derivative of inside the bracket, which is 3. Now all the 3's here combined together become 27. Negative times negative become positive. 2 times 2 is 4. That's my fraction. And then the new power I get here is -5/2. And since t is greater than or equal to 0, this expression will always be positive. and that means it will never be 0. Question number 3. A function f is such that f of x equals to ln 2x plus 1 for all the x's greater than negative half. Write down the range of f. Well, if you recall, the range for logarithm functions is all the real numbers, and if I were to draw the logarithm functions, basically they would look something like this, where the shadow of my function would cover all the y-axis, and basically that's my range, which is all the real numbers. Now, a function g is such that g of x equals to 5x minus 7 for x belongs to R. In part B, I have to find the exact solution of the equation g of f of x equals to 13. So the first thing I need to do, I have to substitute f of x into g, because that's what this composite function is telling me to do. So instead of g of x, I just write g of f of x, and this is f of x, which I'm given its expression in the previous part. And then after that, you need to replace all the x's in g of x with this guy, because this is my new entry or the input. So I get 5 times this minus 7. And as the question mentioned, it has to be equal to 13. Now I've got myself an equation which x needs to be found. Of course, I bring 7 to the other side. I get 20. I divide both sides by 5 to get rid of the coefficient here. I get 4 on the right hand side. Now how to get rid of the ln? I can use the number e. As you all know, e to the power of ln x is just x. And I'm using that property here on the left hand side, so I get 2x plus 1 equals to e to the power of 4. You make x the subject of the equation by bringing 1 to the other side, making it negative, and divide both sides by 2, and that's the final answer. In part C, I have to find the solution of the equation of f prime x, or the first derivative of f, equals to inverse function of g. So that means I need to find these two guys first and then put them equal to each other. So f of x, I have written it here again. If you want to take derivative of ln, you can refer to the formula. So the derivative of ln x is basically 1 over x. However, here I have to use chain rule. That means I get 1 over the argument of my logarithm, which is 2x plus 1, and multiplied by the derivative of inside, which is 2. Therefore, I get this fraction. For g of x, I need to find the inverse function. This is an easy function to find the inverse function of it, because all the inputs are multiplied by 5 and then 7 subtracted from it. So if you want to reverse the process, so basically you add 7 to x and then you divide it by 5, and that's what I get here. But you can also use the conventional way of writing things in the word of x and y, swap x and y, make y the subject of the equation, and then don't forget to change the notation to the inverse function, and you get the same thing as I said earlier. You put these two fractions equal to each other, you got yourself a nice quadratic formula. You can verify that by expanding this bracket. Now you bring everything on one side, tidy up, and you just solve for x. I get 2 answers for x. Obviously, one of them is rejected because this is not inside my domain, and the other one is accepted, which is the final answer. Question number 4, part A. I'm given a graph, which you can see it here in the diagram, and I'm told that this curve represents the absolute value or modulus function of f of x, where f of x is a cubic, and I have to find the possible expressions for f of x. Now, here's what I do first. Since these are for sure the roots of my cubic expression, as the curve is crossing the x-axis at these points, so the linear factors can be found easily by bringing these numbers to the left hand side and put the whole thing equal to 0. So my 3 linear terms are x plus 1, x minus 1, and x minus 3 respectively. Now I just have to worry about the coefficient in front of x cubed term, or the leading coefficient. You can call it A. Over here, I prefer to call it K. So basically, if you expand it, you get something like that. So this guy decides whether the cubic goes like that or it goes like this. Now, here actually you could have both scenarios, and if you just imagine it, I go all the way down and then go up and then all the way down. That's one possible scenario, because what the absolute value does, it flips these two these branches, and mirror it about x-axis, and this is the final graph that I get. Or it would be the other way around, where we go down like that and then go up and then leave the page from here. And also if you flip it, the final result would be the same as you can see here. That's why the question is asking for the possible expression. So there are two answers, and that's what the K here is for. So after you substituting all the linear factors, since I'm given this y-intercept, which is 24, I can put it equal to 24 when x is 0. So basically when x is 0, this whole thing becomes 24. So I replace this with zeros, and that's what I got there. And then the absolute value of 6k is 24, where k could be positive or negative 4. And that's the final expression for f of x plus minus 4 times x plus 2 times x minus 1 times x minus 3. In part B, I'm given an xy axis, and I have to sketch the graph of y equals to absolute value of 2x plus 1 and the graph of y equals to absolute value of 4 times x minus 1. I have to state the coordinates of the point where the graphs meet the coordinate axis. Now, you can use the conventional way by just plugging the points, the critical points, and then connect those points together, keeping in mind that these graphs should have the V shape. So I'm gonna start with the first one. When y equals to 0, this expression becomes 0. That means you can remove the absolute value. So 2x plus 1 is 0, 2x is negative 1, and x is negative half. And that's the point there, right there. And now I need to find the y-intercept. I can find it by putting the x equals to 0. Therefore, y becomes absolute value of 2 times 0, which is 0, plus 1, and the final answer would be 1. And that's what you got there. So you just draw the famous V shape, which presents this graph. Also for the other one, you do the same thing. For y equals to 0, you find the respective x, and for x equals to 0, you find the respective y, and those points are 1 and 0, and 0, negative 4, and you get this nice V shape. You can also use the shortcut, which is transferring graphs. If you recall what the coefficient present, which is basically responsible for widening and narrowing this V, and this number right here is responsible for moving the graph to right and left, or in other words, horizontal shift. Now in last part, I have to find the exact solutions of this equation. Now hopefully I can get help from the graph, the previous part. So as you can see here, the positive branch or the positive side of the 2x plus 1 is intersecting with the positive and negative side of 4 times x minus 1. And that's what I did here. So one time I put it equal to 4 times x minus 1, the other one to the negative version of it, and each one of them leads me to a unique value for x, as you can see here and here. Question number 5, part A. Find the vector which is in the opposite direction to 15 and negative 8 and has a magnitude of 8.5. So first of all, I'm interested in finding the magnitude of this vector, because then I'm gonna use the scalar properties to apply and find the new magnitude. So since the magnitude of this vector is 17, I can use the Pythagoras theorem. This is my x component, raise it to the power of 2, y component, do the same thing, and then add them up, take the square root of the answer, and you get 17. And now, since 8.5 is half of this value, I can basically just multiply this by half. However, take note of the opposite direction. So that means the positive x now has to be negative, and the negative y now has to be changed to positive. Therefore, I'm going in the opposite direction. Now in part B, I have to find the values of a and b such that this equation holds. So this is quite an easy equation to solve. All you have to do is just to consider all the x's together. You form one equation, and all the y components together as well. You get yourself a simultaneous equation where the unknowns a and b can be solved. So if you tidy up for the first one, you get 11a minus 6b equals to -1. For the second one, 2 goes to the other side, so you get 10 on the right hand side, 5b on the left hand side, which leads to the value of b to be 2. You go back to the first one, substitute b with 2, and you get 11a to be 11, which means a has to be 1. Question number 6, part A. I have to write down the values of k for which the line y equals to k is a tangent to the curve y equals to 4 sine x plus pi over 4 plus 10. Now for this question, you can go ahead and take derivative. However, I don't suggest you to do that, because after all, it's just a 2 marks question, and whoever designed this question, they didn't want the students to take that path. There is an easier path. Well, what I did, I drew this curve. I did it step by step so you can follow. And why I did that, because basically when they say a line y equals to k, so these lines are horizontal lines, right? And if it's supposed to be tangent to this sinusoidal curve, that means it has to either touch the crest or the trough, right? The peaks, basically, the maximum or minimums. So I just did that. I just drew this graph so that you could see the maximum and minimums easily, and therefore find those two values. So I start with y equals to sine x, which is this, and then I applied the coefficient 4, which is responsible for stretching my curve along the y-axis by a factor of 4. So from 1, basically I go to 4 now, also -4, and then I have to shift everything 10 units up. So I go 10 units up, 4 becomes 14, and -4 becomes +6. Now I did not consider this part because it's irrelevant to the answer that I'm supposed to find. This is responsible for moving the functions to the right and left, and it's got nothing to do with the amplitudes. Therefore I ignore it here. And the answers are y equals to 14 and y equals to 6. In part B, part 1, I have to prove this identity. So basically, whenever you come across an identity, it's a good idea to start from the biggest side. In this case, that would be the left hand side. And after performing some algebraic manipulation and the identities that you know, and using the famous identities that you know, hopefully you can get to the right hand side. So for the left hand side, I'm gonna start with combining these two fractions and get a single fraction. I can do that by multiplying the numerator of the first fraction by the denominator of the second fraction, as I did here. Same thing here. I multiply the numerator of the second fraction by the denominator of my first fraction. So, and then I expanded these brackets, and as you can see, I get 1, then tangent theta, cosine theta, and tangent theta, cosine theta. For the next two brackets, I did the same thing, and I got 1 minus tangent theta minus cosine theta plus tangent theta, cosine theta. Well, the tangent theta and cosine theta are gone over here, and 1 and 1 becomes 2. I have two of these terms, tan theta, cosine theta. That's what I got here. Also for the denominator, I get, when I multiply these two, I get 1 minus cosine squared theta, and I use the Pythagorean identity and replace it with sine theta, because that's what I'm aiming for after all. And I keep that for the rest of my work. And now I get back to my numerator to see whether I can get to 2 times 1 plus sine theta or not. Well, since I'm looking for a sine, I'm gonna change the tan theta to sine theta over cosine theta. That causes the cosine theta to disappear. And then after all, I just have to factor out a 2 to get what I'm looking for, which is the right hand side. In part 2, I have to solve this equation. Please take note of the word hence. So whenever you see this word, that means you have to get help from what you have obtained in previous part. Now in previous part, I know that this expression can be replaced by its equivalent, which is 2 times 1 plus sine theta over sine squared theta. And that's what I did right here. You put it equal to 3, you cross multiply, and hopefully everything is in the word of sine theta, and I do not need to make any changes. I just bring everything to the left hand side. Now at this point, I get a quadratic equation, and I can solve it using quadratic formula. All I have to do is to determine my a, b, c, and just use the famous formula, negative b plus minus the discriminant, which is b squared minus 4ac over 2a. You make the substitution, make sure you don't make any careless mistake with the signs, and then you simplify. Your discriminant becomes 4 plus 24, which is the square root of 28, and square root of 28, you can simplify it. Since 28 is 4 times 7, the 4 can come out and becomes 2, and now I can factor out a 2 from top and bottom. I can cancel it out, and I get 1 minus the square root of 7 over 3. Now if you use your calculator, what you get is this angle, which is negative 33.3 degree, and it's in degrees since my original domain is given to me in degrees, so the answer is also expected in degree. However, this is out of my domain, so what I need to do is to find the other answers. And if you recall, if this is the sine curve, so the answer I have here is basically negative 33.3, which is this. So if I just extend this line, I can get 2 other answers, which is within the domain from 0 to 360. One of them can be found easily just by adding 360, because the period of sine functions is 360, so I can get the next answer easily. For this one, well, you can use the fact that sine curve is symmetrical from 180 to 360. So if this is one of my answer, I can obtain the second one by just adding 33.3 to 180, and that's what I get here. So these are my 2 answers. Question number 7, part A. The first 3 terms of an arithmetic progressions are given to me, as you can see, and I'm told that the sum to n terms of this progression can be written as 256 log 81. Find the value of n. So since I'm told that this is an arithmetic progression, I'm just going to go ahead and find the common difference. After all, I need that because I'm going to be using this formula for the sum of the terms up to a certain value. So finding the d can be very easy task. You just have to take 2 consecutive terms. In this case, I chose the second one and the first one. You subtract them from each other. However, you need to apply the law of logarithms by bringing these 3 inside. You make it the power of the argument. So 3 cubed would be 27. And then how can I combine these 2? Since the sign between them is minus, I can use the fraction. So LGR a minus LGB is basically logarithm of a over b. Now, as soon as you find the common difference, which is logarithm of 9 to the base 10, you can go ahead and make the substitution in this formula. You just have to tidy up, expand this bracket, obviously, and then bring the 2 in front of log 3 inside and make it the power of 3. So we get log of 9, and with this negative log of 9, it disappears and you end up with n log 9, and it comes out of this square bracket. You multiply it by n over 2, which leads to n squared over 2 log 9. You take this and you put it equal to 256 log 81, because that's what we're told the sum to n terms of this progression is. And then now the goal is to find the n. What I did here, at first I got rid of the 2 here. I multiplied both sides by 2, and then I needed to make my logarithms look the same. So therefore, instead of 81, I wrote 9 squared, where the 2 could come in front and be multiplied by 512, which results in 1024. And the log 9 from both sides can cancel out, so you're left with n squared to be 1024, which results in n to be 32. In part B of this question, I'm told that the first 3 terms of a geometric progression are these values. Find the sum to infinity of this progression, giving your answer in the form p ln 2. Now I want to recall the formula for the sum to infinity, which is the first term divided by 1 minus common ratio. Having said that, I need to have my common ratio first, and that's what I did over here. I just took 2 consecutive terms, the second one and the first one, and divide them by each other. So I cannot make this division unless I have the same logarithm. So 16 can be written as 2 to the power of 4, and then 4 goes in front as I did here. 256 on the other hand can be written as 2 to the power of 8. 8 also can go in front of the ln, so I'm just left with 4 over 8 because the ln is cancelled from top and bottom, which is nothing but half. After that, you just come here, you make the substitution. The first term is ln 256, and in the denominator I get nothing but half, and anything divided by half, it's the same as multiplying it by 2, and that's what you get here. But since they ask for a specific format, they want ln 2, again I'm gonna rewrite 256 as 2 to the power of 8, where 8 can go in front, with these 2 becomes 16, and the ln 2 will remain there. Therefore, this is the final answer, which means P has to be 16. Question number 8, part A. Find the exact coordinates of the points of intersection of this curve and this line. Well, whenever we're asked to find the intersection of 2 curves, you just need to put the equation of those curves equal to each other and basically get rid of the y's, and now everything is in the world of x. I bring everything to one side, and this is obviously a quadratic equation. So my a is 1, b is negative square root of 5, c is negative 30. So I can just go ahead and apply the quadratic formula, which is negative b plus minus square root of b squared minus 4ac divided by 2a. You make the substitution. Over here, the negative is gone. Over here, the 5 can come out since the 2 takes care of this radical sign. And then negative 4 times negative 30 is 120, with the 5, 125. And the square root of 125 is 5, the square root of 5. And I can separate these two values. So at one time, I consider the positive sign. So that means I get 6 square root of 5 over 2, which is 3 square root of 5. And the other time, I consider the negative sign, which results in negative 4 square root of 5 over 2, which is negative 2 square root of 2. Now each of these x's, they have a corresponding y, which you can find it by going back and plug it in either equation of these curves. However, I choose the line over here because it makes my calculation easier. Therefore, you can see here 3 square root of 5 times 3 square root of 5 is basically 9 times 5 or 45, plus 10 is 55. And you do the same thing here, which results in negative 20. So the points are basically 3 square root of 5, 55, and negative 2 square root of 5 and negative 20. In part B, it is given that tan theta equals to this fraction where theta is between 0 and pi over 2, excluding those values. Find the cosecant square theta in this form. Now, if you recall, I can write cosecant square theta as 1 plus cotangent square theta. The reason I did this because tan is also linked to cotangent. Basically, cotangent is nothing but the reciprocal of tangent. And that's what I did here. I swapped the numerator and denominator. However, since this is the format they want, I need to rationalize this fraction first. That means I need to multiply top and bottom by the conjugate of the denominator, which is the square root of 3 plus 1. And once you do that, in the denominator, you can use the difference of squares, which basically says a plus b times a minus b is nothing but a squared minus b squared. So square root of 3 square is 3 and 1 square is 1. That's what I get here. 3 minus 1 is 2. In the numerator, however, I need to expand this bracket and I get 2 square root of 3 plus 2 plus 3. I get that from multiplying square root of 3 by itself basically, and then square root of 3. So I can combine the like terms. I get 3 square root of 3 plus 5. Now I need cotangent square. So cotangent square can be obtained just by raising this guy to the power of 2. And you can start by raising the numerator to the power of 2 and then denominator to the power of 2. For the numerator, you can use now this identity, the square of sum, which is the first term square plus double of the product plus second term square. That's why I color coded them here. You can see the changes that happen. And then you tidy up. You get rid of the brackets. 3 square root of 3 square. So 3 square is 9. Square root of 3 square is 3 times 9 is 27. Over here, I get 5 times 2, 5 times 3, which is 30 square root of 3. 5 square is 25. So you combine that, you get this fraction in the end. Now this is cotangent square theta. So if I just add 1 to this, I get cosecant square theta. And that's what I was aiming for right from the beginning. So I'm just gonna go ahead and add this to 1. And over here, 1 is basically 4 over 4. And that's why you see the 4 right there. Again, you add the integers there. So this is the only third that I have here. Therefore, it remains untouched. I have 56 plus 30 square root of 3. And these are all divisible by 2. So you can just go ahead and divide it by 2 and you get 14 plus 15 over 2 times the square root of 3, and that's the final answer. Question number 9. A circle center O and radius r centimeter has a sector OAB of fixed area 10 centimeters square. Angle AOB is theta radians and the perimeter of the sector is p centimeter. Find an expression for p in terms of r. As you guys know, the area of a sector, if the subtended angle is in radians, can be found easily by using this formula, which is half of theta r square. And for the perimeter, all you have to do is to add up the r here and also the r here and the length of the arc, which can be found also using the formula r theta. So as soon as you establish a formula for area and p, then you can relate P to the R by trying and eliminating the theta. So from the first equation I obtained up here, I can make theta the subject of the equation, which is 20 over r squared. You just go back here, replace theta with 20 over r squared, which results in 20 over r plus 2r. In part B, I have to find the value of r for which P has a stationary value. And as you all know, in order to find the stationary value, I just have to take derivative and put it equal to 0. If you take derivative of this, the power goes in front, you get negative. You need to subtract 1 from the existing power, which becomes negative 2. And here r vanishes and you're just left with the coefficient of it. So this is the first derivative. You put it equal to 0 for simplicity. I brought the r down and I changed the power to positive. And now over here, you bring the 2 to the other side, it becomes negative 2. You need to make r squared the subject of the equation. So you can cross multiply negative 20 over negative 2, which is positive 10, and r is square root of 10. You need to neglect the negative value since r is radius. That means it has to be positive. In part C, I have to determine the nature of this stationary value. You can proceed by taking the second derivative. If you recall, the first derivative was this. Now the second derivative, again, negative 2 goes in front. With the negative 20 becomes positive 40. You subtract 1 from the power, and the derivative of constant is just 0. And I get 40 over r cubed. Now I just have to go ahead and substitute the value of r, which I found here, into this expression and determine the sign of it. So over here, 40 divided by square root of 10 to the power of 3. You don't need to calculate the exact value. You just need to know whether it's positive or negative. And this is obviously a positive value. Therefore, it is a minimum. In part D, you have to find the value of theta at this stationary value. So if you recall, in part A, I found theta to be 20 over r squared. Now I just have to replace r with the square root of 10, which becomes 20 over 10. These 2 with the radical is gone. These 2 with the radical sign is gone. 20 over 10 is 2, and that's the final answer. Question number 10. The normal to the curve y equals to tan 3x plus pi over 2 at the point P with coordinates P and negative 1, where P is between 0 and pi over 6, meets the x-axis at the point A and the y-axis at the point B. Find the exact coordinates of the midpoint of AB. Okay, so this question is a little bit lengthy. It carries 10 marks. But the procedure is quite straightforward. So I just have to find the equation of the normal line and see where it cuts the x and y axis respectively. Those points would be A and B, and then find the midpoint, and that would be the answer to the question. But before that, I do not have the x coordinate of P. However, since P lies on the curve, that means it must satisfy the equation of the curve. So you just go ahead and substitute y with negative 1 and x with P. This is what you get. You can take arc tan from both sides. So which angle its tangent is negative 1, that is 3 pi over 4 in the second quadrant. In the first quadrant, the tan of pi over 4 is 1. The tan of 3 pi over 4 is negative 1, since sine is positive and cosine is negative. So you just bring the pi over 2 to the right hand side to isolate the P. You get pi over 4 on the right hand side. Then you divide everything by 3. So P is pi over 12. So this is the coordinate of point P. Then if you want to find the normal, first thing you have to do is to find the tangent. And tangent can be found by taking derivative of the equation of the curve. Since this is a tangent function, the derivative of tan is secant square. So You need to be careful here because we're dealing with a composite function. Therefore, I have to apply chain rule. That means derivative of outside, which is secant square of the argument, and then times derivative of inside, which is 3. Now, if I want to find the slope of the tangent, I need to substitute the value of x and y for point P into this equation, the value of x for point P, which I already found over here, pi over 12, into the derivative which I found. So I get 3 pi over 12, which simplifies to pi over 4 plus pi over 2 results in 3 pi over 4. And that's a famous angle. If you recall, secant is nothing but 1 over cosine. So what is the cosine of 3 pi over 4? That would be negative square root of 2 over 2. The reciprocal of that would be negative 2 over square root of 2. Watch out for the power 2 here. And then you need to multiply it by 3. So you get 6. Now, if the slope of the tangent is 6, the slope of the normal should be the negative version of the reciprocal of that, because if two lines are perpendicular to each other, the product of their slope is always -1. And now that I got the slope of the normal, I can go ahead and find the equation of the normal line, because I have the slope and I have the point P which lies on that line. So this is the equation. This is the formula for the equation of a straight line. You can just substitute m with -1 over 6 and x naught and y naught with pi over 12 and -1 respectively. So this is the equation of my normal line. You don't need to tidy up. All we need here is to find the x-intercept and y-intercept. So for x-intercept, y is equal to 0. I put the y equal to 0 and try to find the value of x. You need to isolate x. So bring everything else to the other side. And over here, I'm going to multiply everything by -6, which results x to be pi over 12 minus 6. For the y-intercept, I do the same thing. Now this time I have to put the x equal to 0, which results in vanishing this term. And then I have y plus 1 equals to pi over 72, which means y has to be pi over 72 minus 1. Now that I have x and y coordinates of points A and B, I can just find the midpoint. So don't forget, the x coordinate of A is this, however the y coordinate is 0, the x coordinate of B is 0, while its y coordinate is pi over 72 minus 1. So you just add up the x's and take average. You add up the y's and divide by 2. And once you do that, you get these coordinates, which is the coordinate of the midpoint, and that is the final answer. Having said that, this was the last question for this paper. I hope you enjoyed the video. If you have any question, please leave it in the comment and I'll be more than happy to help you. See you in the future videos.